Every Mars colonization proposal begins with optimism and ends with radiation math. The atmosphere is too thin, the magnetosphere doesn't exist, and the solar storms don't care about your habitat's regolith shielding. You volunteered for the Mars colony because the pitch was perfect: humanity's backup plan, new frontier, ticket to immortality. What they didn't mention is that Mars has no magnetosphere to deflect cosmic radiation. What they skipped over is that the atmosphere is 1% as thick as Earth's and provides almost no shielding. What they forgot to calculate in the recruitment video is that you're standing in an invisible particle beam accelerator that never shuts off. The numbers don't negotiate. Mars surface radiation averages 0.67 millisieverts per day. That's 240 to 300 millisieverts per year. For comparison, human beings in developed nations are exposed to 0.62 rads per year on Earth. For context, a chest X-ray delivers 0.2 millisieverts. You're absorbing 3 chest X-rays worth of radiation every single day just standing there. During solar particle events, the dose spikes higher, 8,100 micrograys per event, the equivalent of 30 chest X-rays from a single solar storm. On Earth, the magnetosphere deflects most of these particles. Earth's magnetic field is roughly 50 microteslas. Mars has 0. The math is simple. No magnetic field plus 1% atmospheric density equals full exposure continuously forever. The radiation isn't acute. That's the trap. You don't feel cosmic rays breaking your DNA strands. You don't notice the immune system degradation accumulating in your bone marrow. Central nervous system effects, cataracts, cardiovascular damage, cancer, they build silently, probabilistically, inevitably. The question shifts from will radiation kill you to which radiation-induced failure kills you first. Your cells are taking hits every second. High-energy particles sever DNA, disrupt proteins, damage cellular components. Some damage your body repairs. Most of it just stacks up, compounding, until something critical fails. Studies indicate that while the human body can withstand a dose of up to 200 rads without permanent damage, prolonged exposure to the levels detected on Mars leads to acute radiation sickness, increased cancer risk, genetic damage, and death. Everyone believes engineering will solve this. Elon Musk's optimism versus thermodynamic reality. The plan sounds logical. Build underground habitats, use meters of regolith for shielding, live in lava tubes. Great! Now you're growing food underground with artificial light in a civilization that needs sunlight for agriculture. Every supply shipment from Earth is 8 months away minimum, 225 million kilometers, one way. Your hydroponic system fails. Your colonists are already immune compromised from radiation exposure. And you can't grow enough backup crops in caves to sustain a population that was supposed to be expanding. The food production problem compounds the radiation crisis. Conventional wisdom says Mars colonists will use hydroponics, closed systems, controlled nutrients, minimal soil. But hydroponics requires equipment shipped from Earth, continuous nutrient supplies, and nitrogen extracted from the Martian atmosphere through chemical reactors. When that system breaks down 8 months from the nearest spare parts, you pivot to dirt farming. Martian regolith is toxic, packed with perchlorates that destroy thyroid function. You need to remove the perchlorates, add nutrients, build organic carbon content through cover crops, introduce vermiculture to breed worms for composting. That takes time. Soil remediation takes years. And every hour spent outside tending those crops is another radiation dose accumulated in tissue that's already compromised. Growing crops on Mars means choosing between 2 bad options. Surface farming exposes your colonists to continuous cosmic radiation and solar particle events. Underground farming requires massive energy inputs for artificial lighting, enough to power a small city just to grow wheat and legumes in pressurized caves. Your colony operates under limited space, limited energy, and limited Earth supplies. Intercropping systems might optimize resource use, but they don't solve the fundamental problem. Food production on Mars requires human presence, and human presence means radiation exposure. Even if you build greenhouses with regolith shielding overhead, someone has to maintain the systems, repair the seals, manage the pollination. Bees need isolation to prevent escape. Crops need air circulation. Your farmers accumulate millisieverts while the colony's cancer rates climb. The shielding problem is worse than the promotional materials admit. Lead stops X-rays, not cosmic rays. The particle energy spectrum is wrong. You need meters of regolith above every habitat module, which means excavation infrastructure you don't have and won't have for decades. Research shows that 5 centimeters of Martian regolith can reduce solar energetic particle event exposure by approximately 60%. A few meters of soil covering surface habitats could theoretically support long-term habitation, but those are models, not certainties. Galactic cosmic rays and solar energetic particles interact with the thin Martian atmosphere and penetrate into the regolith, producing secondary particles, neutrons and gamma rays, that contribute to a complex radiation environment quite unlike Earth's surface. You're not just shielding against primary radiation, you're shielding against cascading secondary radiation generated when cosmic rays collide with Martian soil. The regolith reduces primary particle radiation by 41% on average, but that still leaves 59% getting through.
Solar storms penetrate all the way to the Martian surface because that 1% atmosphere isn't enough to stop them. Astronauts on the International Space Station see fireworks when radiation particles pass through their retinas during solar events. They're protected by Earth's magnetosphere, and they still take cover in their Soyuz capsules when violent solar storms hit. Mars colonists get the full dose, on the surface with no evacuation option. The radiation levels on Mars are roughly comparable to those on the ISS. Astronauts have lived in space for nearly a year without significant issues. But the ISS is temporary. Colonization is permanent. The difference between a one-year mission and a lifetime of exposure is the difference between manageable risk and statistical certainty. Over 18 months, the Mars Odyssey probe detected ongoing radiation levels 2.5 times higher than astronauts experience on the ISS. Living on Mars is like living next to Chernobyl reactor number 4, except the radiation never decays. There's no evacuation route, and your food supply depends on staying outside. You could minimize exposure with underground construction, but that's not colonization, that's bunker survival. Growing sufficient food requires surface agriculture or massive underground complexes with enough artificial lighting to power a small city. The energy requirements are staggering. The failure points multiply, and your colonists are accumulating radiation damage every single day they're there. The biological math is unforgiving. A round trip to Mars with time on the surface totals roughly 1,000 millisieverts of radiation exposure. That's not colonization, that's a short visit with a return ticket. Colonists don't return, they stay. Years accumulate into decades. Radiation doses climb into ranges where cancer rates spike, immune systems collapse, sterility sets in. Your colony's population curve inverts. The settlers you sent can't reproduce safely. The children born there face even higher cancer risks because their developing cells are more radiosensitive. Mars doesn't need to kill you violently, it just needs to wait.
There is no solution with current technology. Models predict radiation levels, shielding designs get tested, materials get evaluated. But existing surface measurements are at discrete locations, not where Starship will land, and radiation models include multiple assumptions and uncertainties that must be validated with on-site data. You're gambling with human lives on incomplete information. You're betting that regolith shielding and underground habitats will reduce exposure enough to matter, when the background cosmic radiation alone is 40 to 50 times higher than Earth.
The dose equivalent rate on Mars ranges from 156 to 274 millisieverts per year, depending on the solar cycle. And that's before accounting for solar particle events. The radiation exposure during transit to Mars remains within NASA's established lifetime limits, but the key uncertainty is a major solar storm, which would require a heavily shielded shelter for the entire crew. On Mars, there is no shelter adequate for a civilization, only temporary refuge for temporary survival. The irony is sharp enough to cut through a pressure suit. The backup planet for humanity is less habitable than the Antarctic seafloor. We're debating Mars colonization when we can't even maintain astronaut health on the ISS, where evacuation is 11 hours away, and Earth's magnetic field still provides partial protection. On Mars, there is no evacuation. You're 225 million kilometers from help. If a solar storm hits and your shelter fails, you absorb several hundred rem of radiation, enough to cause severe radiation sickness and a 10 to 20% risk of death in the short term. The survivors face a 5 to 10% increased cancer risk for the rest of their shortened lives. Any crewed missions to Mars will need radiation shielding and countermeasures, and any long-term stays will have to be built underground or hardened against solar and cosmic rays. There's no way around it. At present, the radiation on Mars is hazardous, period. Mars will accept your colonists. It just won't let them reproduce or survive long enough to matter. The physics doesn't care about vision or ambition or the dream of a multiplanetary species. Cosmic rays carry so much energy they knock electrons off atoms and disrupt molecular structures of any material in their path. They damage machines, they damage tissue, they damage futures, and they never stop. The radiation is continuous, cumulative, and patient. You can build underground. You can pile regolith overhead until your habitats look like burial mounds. But every time a colonist steps outside to repair a solar panel or check a seal or tend a nitrogen-fixing clover crop in toxic regolith, the clock is ticking. Every EVA adds dose. Every solar storm compounds risk. Every year on Mars brings you closer to the failure point that will kill you. Rule 37. You can't engineer your way out of missing a magnetosphere. Physics wins. Always.